In this lesson, we're going to talk about probability distributions and expected value. We've talked about probability distributions in a previous lesson, but we're going to talk about it in more depth in this lesson. So looking at the definition of a probability distribution, we have that it's a listing of all the possible values of a random variable, which is all the possible outcomes. Along with the probabilities of those values occurring. So it's going to be all of their corresponding probabilities. Each probability must be between 0 and 1, and the sum of all the probabilities must be equal to 1. Let's look at example 1. It says, complete the following probability distribution. All of these probabilities are between 0 and 1 for the variable x is equal to 0, 1, 2, and 3. We have a missing value in the table for x is equal to 4. So in order to figure out what that probability is, I know that the total of all of these should be 1 when I add them all up. So in order to figure out what that missing value is, I'm going to add 0.25 plus 0.17 plus 0.22 plus 0.18. And when I add those all up, I get 0.82. Since the sum needs to be 1 for a total of all of them, then what's left over is 1 minus 0.82, which is equal to 0.18. So the probability for x is equal to 4 is going to be 0.18 in order for this to be considered a probability distribution. Looking at example 2, we are going to make a probability distribution based on the information that's given to us in the problem. Emily plants vegetables in her backyard garden 3 times a week. It says 25% of the time she doesn't plant on any of those days. 15% of the time she plants on exactly one of those days. 20% of the time she plants on exactly 2 of those days. And 40% of the time she plants on all 3 days. Now, the days is our variable. X is the number of days planted. And so since she plants up to 3 times a week, we could have 0 days, 1 days, 2 days, or 3 days. All of the probabilities for the chart is given here. So we just have to make sure that we match the corresponding probability in the table. So 25% of the time she doesn't plant on any day. So that's when x is equal to 0. So for the probability, I'm going to put in 0.25, 25%. 15% of the time she plants on exactly 1 day. So that means when x is equal to 1, the probability of x is going to be 0.15. 20% of the time she plants on exactly 2 days. So when x is equal to 2, the probability is 0.2. And then 40% of the time she plants on all 3 days. So that's 0.40. Now let's check to make sure they add up to 1 to verify that this works. So if I take 0.4 and 0.2, that gives me 0.6. If I take 0.5 and 0.15, that gives me 0.4. And when I add 0.4 and 0.6, we get the sum is 1. So this works.